Welcome to the Crazy Hat Chemist. So here we go. Lewis structures number 5. Okay, drawing Lewis dot structures number 5. We're going to draw the Lewis dot structure for carbon dioxide. So hopefully you have reviewed your rules on drawing Lewis dot structures. Okay, the rules for Lewis dot structures and the exceptions therein. You have a piece of paper and a pencil out. And then you're going to write out the formula for carbon dioxide. This is two nonmetals. This is a binary nonmetal compound using prefix naming. That's why the di is there. Prefix naming. Di. Di is for what number? 2. So there's 1 carbon, there's 2 oxygens, so it's carbon dioxide. Okay, you're going to look on your periodic table and find out the group number in which carbon is in and the group number in which oxygen is in. That will give you the number of valence electrons for each respectively. Carbon is in group 4, so it has 4 valence electrons. Oxygen is in group 6, so it has 6 valence electrons. There's 1 carbon and there are 2 oxygens. We're going to sum these 2 up and then we get a total of 16 electrons. 16 total electrons, but remember, we always work in pairs of electrons. It's faster and easier. So I'm going to divide this 16 by 2, and that will give me 8 pairs of electrons. Okay, so that is, in my bond blender, I'm going to take and place 8 pairs of electrons inside my bond blender, and I'm going to shake them up. Okay, so I'm going to get the 8 pairs of electrons. I'm going to hold on to that right now. Now, in order to draw the Lewis dot structure, I'm going to do a plus sign. And then the least electronegative goes in the middle. The least electronegative element goes in the middle. That is the one that's furthest from fluorine. Okay, oxygen is right there next to fluorine. It's the second most electronegative element, so it's not the oxygen. Therefore, it's the carbon is the least electronegative element that goes in the middle. Okay, now the 2 oxygens go around the carbon. 2 oxygens go around the carbon like thus. Okay, now my first rule of placing electrons from my bond blender is I'm going to place a pair of electrons between the central element and the outside element. That is, the central element is carbon, the outside elements are oxygen, so here is a pair of electrons between the central and the outside elements. I've used up 2 of my pairs of electrons. Okay, now my next rule is to place pairs of electrons, that is, on the outside elements. Okay, and I am going to place the rest of the pairs of electrons on the outside elements. Those are the oxygens. Now, I have used up all the pairs of electrons that are in my bond blender. That is, I have used up 8 pairs of electrons. There are 16 electrons here. I am going to verify the octet rule for oxygen. Okay, now the oxygen, both of the oxygens have an octet, that is 8 electrons. It's period 2. It must have an octet. Okay, now I'm going to look at that carbon. So take a look at that carbon. I've circled that here in blue for you. And the carbon is deficient in an octet. It's deficient because it only has 4 electrons. It must have 8 electrons around the carbon. Okay, so this is what we're going to do. We're going to follow our next rule here, and our next rule is the rule where we do multiple bonds. That is double bonds and triple bonds. So we're going to take a look at these 2 pairs of electrons on the outside of the oxygens. Now, I have to maintain 8 electrons around each oxygen, but I can move the 2 circled red ones, pairs, towards the bond in between the carbon and the oxygen for each pair of electrons. And that will give me 4 electrons between the carbon and one of the oxygens, and then another 4 electrons between the central carbon and the other oxygen. And that will give me 8 total electrons in the carbon. And that will be a double bond on either of the oxygens. Okay, and then I will only have 2 pairs of electrons that are lone pairs of electrons on the outside oxygens. No lone pairs on the central carbon. And then eventually you draw lines for bonding pairs. A single line is a single bond. 2 lines is a double bond, so this is why I get this structure. That is the carbon in the middle, and then 2 double bonds with the carbon. Okay, each line represents a pair of electrons. So if I put a giant circle around that carbon, I see 4 lines around the carbon. Each line is representing 2 electrons, so I've got 8 electrons. That's the octet rule for carbon. And if you put a circle around each of the oxygens, then each oxygen has 2 lines and then another 4 electrons. So each line represents 2, that's already 4, and then the 2 lone pairs of electrons, that's again a 4, and that's 8 electrons. So I have 8. The octet rule has been satisfied for the carbon and the oxygen. Okay, if you like that video, give me a thumbs up, subscribe to my channel, and don't forget, here is my crazy hat. Boom! It must be cold somewhere. Have a good day! Bye now.